This section that we're going to cover now is primitives or antiderivatives. It is an important application in sciences. We will start by defining what antiderivatives are, then we discuss their graphical meaning and interpretation. The primitive of a function f of x, small letter or lowercase, is another function f of x, uppercase, such that capital F equals integral. This symbol is known as integral or primitive of f of x dx. This is equivalent to having small f of x being a derivative or the derivative of capital F of x. Some common primitive rules that we need: integral or antiderivative of f of x plus g of x all dx is integral of f of x dx plus g dx. So the integral of a sum is nothing but the sum of integrals. Mainly, this is known as the golden rule for antiderivatives or for primitives. Integral of x to the power m dx is 1 over m plus 1 x to power m plus 1 plus a constant. So this is the major difference between integrals and derivatives, or antiderivatives and derivatives. A definite integral of a function is also a primitive or an integral, however it's evaluated between two boundaries. So when you say integral from a to b of f of x dx, it equals capital F, which is the primitive of small f that we discussed before, but evaluated at b, the upper boundary, minus f of a, where a is the lower boundary. This is known as the definite integral, or simply an integral. Graphically, what does a primitive stand for? When we go to start writing integral of f of x dx, think of the part f of x dx. If you look at the graph here, it is simply as if you're multiplying the width of this rectangle by the height or the length of this rectangle. So the definite integral between 2 points is simply an infinite sum of areas of small rectangles here between the given boundaries. So if you integrate from x1 to x2 or from a to b, add up all these sticks which we have discussed above, add them here together, put them side by side, you notice that you're going to end up with a shape or a shaded region. So from here we can safely say that the integral of a function f of x dx evaluated between a and b is the area of the region bounded by the curve, the x-axis, and the two vertical axes, x1 equals to a and x2 equals to b. This is all about integrals. Definitely we have summarized a month of work in a couple of minutes. Go to your lesson if you have taken it before so that you review it more. This is just a summary, a quick summary about what we need to know related to primitives. Focusing on the main ideas that we might need, try to solve these 5 applications or 5 exercises on integrals or definite integrals, and then discuss your answers with your instructor. Another application which focuses mainly on the graphical interpretation of integrals is application 10. Evaluate the given integrals and you're given the boundaries along with the graphs corresponding to the studied functions. Try to solve this as well and discuss your answers with your instructors. At any time that you feel that you need more help, don't hesitate to write in the comments below. By finishing primitives and integrals, we come to the end of the math part related or required in physics. Thank you for your time. Hopefully we were able to answer most of your questions.